Carbenes are neutral carbon species with two non-bonded electrons that can insert into carbon-hydrogen bonds, add to double bonds to form cyclopropanes, and perform other bond-forming reactions, and they are used whenever chemists need to create three-membered rings, introduce new carbon-carbon or carbon-heteroatom bonds, or perform selective insertions. Think of a carbene as a carbon atom that has only 3 attachments and 2 lonely electrons, so it is very reactive and wants to make new connections quickly. Because it is missing a 4th bond, it can either grab another bond by adding across a double bond to make a little 3-sided ring called a cyclopropane, or it can slip into a carbon-hydrogen bond and replace a hydrogen with a carbon group, which is called insertion. There are 2 types, singlet with paired electrons and triplet with unpaired electrons, and that difference changes how they react. Singlets often do concerted additions, while triplets act more like radicals. Chemists generate carbenes from precursors like diazo compounds, ylides, or through metal catalysts, so they appear just when needed and react before they can rearrange or fall apart. Students often think carbenes are stable like ordinary molecules, but most carbenes are extremely short-lived and must be made in the reaction mixture right before they react, so using a stable precursor or a catalyst fixes that problem. Another common mistake is assuming every carbene reacts the same way, while in fact the electronic state and substituents change whether it prefers insertion, addition, or rearrangement, so check the carbene type and reaction conditions before predicting products. Some learners try to run carbene reactions without controlling temperature or light, which can lead to side reactions, so following the recommended conditions and using inert atmosphere or scavengers when advised helps get the desired outcome. For more videos and resources on carbene chemistry and related reactions, check out www.gumballdegree.com.